root, right? That makes it imaginary and that makes it undefined. So those are your two restrictions. I meant at the beginning, not like throughout the entire thing. You should be paying attention. Then move to the front. All right. So let's look at the next one. So we have f times g. So now we have two new functions. So f is 5x to the third and g is x minus 1. So to multiply them together, so we have h of x is going to equal 5x to the third times x minus 1. So we're going to have to distribute the 5x to the third to both, so that gives us 5x to the third, 5x to the fourth, right, because x to the third times x is x to the fourth. And that's going to be minus 5x to the third. So then now we think about the domain. So I said there's only two restrictions. So we can't have square roots. We don't have any square roots, right? And we don't have any fractions. So there's no restrictions. But you guys should also know from what we've already studied, we know that this is a fourth degree polynomial with a positive a value. So you know it looks like a w. And so you know that the domain is from negative infinity and positive infinity, or all real numbers, right? So based on what you guys already knew from the past, you guys should be able to tell what the domain is. So the domain is always the x values. So then now we get to f divided by g. So we're going to say h of x is going to equal f, which is 5x to the third, divided by g, which is x minus 1. So since the denominator has an operator in the middle here, like I can't just simplify the x to the third over x, right? Since it's has an operator in between, like you'd have to pull it out to the front. So this is as simple as we can go with this. So it's simplified already. Now we just have to state the domain. So now that since we have a fraction, we have to consider what would make the denominator of this fraction 0, because we can't have a 0 in the denominator if x was 1. So then here we would say that the domain would be all real numbers, except x cannot equal 1. So, and this one's an easy one to try to figure out what the denominator needs to equal, right, in order to make it 0. But if we didn't know right off the bat, we could just set the denominator to 0 and solve it, and figure out what would make it 0. We good with that? Okay, so why don't you guys go ahead and try to do C and D on the back yourselves.